Hello everyone, Miss Sinclair here. Today we're going to talk about finding the key features of a quadratic or of a parabola algebraically. So yesterday we did this activity where we looked at the 4 different graphs and we found these key features graphically, meaning we looked at the graphs and we decided what the x-intercepts were, what the y-intercept was, what the vertex was, what the axis of symmetry was. Today we're going to be finding those same key features, the x-intercepts, the axis of symmetry, the vertex, and the y-intercept, but we're going to be finding them algebraically. And what I mean by algebraically is we're going to be using math to do it. We're going to be using some algebra to do it. Okay, so let's take a look. I'm going to walk you through how to do each part algebraically, and then we're going to do some practice together. So the standard form of a quadratic equation has an x squared. So it normally is ax squared plus bx plus c, where a, b, and c are numbers. So for example, you might have y equals x squared minus x minus 12. Or you might have y equals negative x squared plus 2x minus 10. The important thing is that it has an x squared. That's what makes it a parabola. The roots, the zeros, the x-intercepts, or the solutions, those are all the same thing. So I could ask you, can you please find the roots? Or I could say, can you find the zeros? Or can you find the x-intercepts? Can you find the solutions? That's all the same exact thing. So the solutions to a quadratic equation are where the parabola crosses the x-axis. So in other words, it's where the y value is equal to 0. So what we're going to do is we're going to take the y value and set it equal to 0. And like I said, we'll be doing some practice in about a minute. You have a brand new formula, the axis of symmetry. So remember, the axis of symmetry is the line that cuts that parabola in half. So here is the equation for the axis of symmetry. X equals negative b over 2a. Okay. The vertex, or your turning point. Well, to find that, we're going to first find the axis of symmetry. And the axis of symmetry is going to be the x value of our turning point. So maybe we found the axis of symmetry was x equals 2. So that's going to be our x value 2. And we're going to substitute that in to the original equation and get a y value. So our axis of symmetry would end up being a point. For example, maybe it would come out to be 2, 3. And the y-intercept is we're going to substitute 0 in for all the x values in this equation, and we're going to solve for y. So let's practice with some of these. So if you have your notes packet, we're going to skip these questions. There's 4 questions we're going to skip, and we're actually going to go right to the practice. And I want you to find this right here. If you don't have your notes packet, hopefully you've printed out these questions that you need. Okay, so let's identify the key features of this quadratic equation. So f of x, remember f of x is like y, so we could say y equals x squared plus 5x. Okay, so to find the roots, the first thing we're going to do is we're going to set y equal to 0. Okay, so do this in a different color. So 0 equals x squared plus 5x. So now, you've done this before. We did this last unit. We set it equal to 0. Now we need to factor and solve. So I need to look at x squared plus 5x and ask myself, what kind of factoring is this? Here comes that factoring again. This is a GCF. So I'm going to factor out a GCF of x, and then I'm left with x times x plus 5. Just going to rewrite it. So now this is where we tee it off and we set each factor equal to 0. So x equals 0, x plus 5 equals 0. Let's minus 5, let's minus 5. So x equals negative 5. So this parabola crosses the x-axis at 0 and at negative 5. Those are my roots, or my zeros. Let's do the y-intercept next. The y-intercept is where the parabola crosses through the y-axis. to find that algebraically, what we're going to do is we're going to set x equal to 0. So I have my equation, y equals x squared plus 5x. Every time I see an x, I'm going to put a 0 in. So 0 squared plus 5 times 0. So in this case, I get y equals 0. So my parabola crosses through the y-axis at 0. Okay. Let's do the axis of symmetry next, and we'll do the vertex at the very end. So the formula for the axis of symmetry, I know it's new, it's something you will have to memorize, but for now, don't worry about it. X equals negative b over 2a. So if I look at my equation, a is 1, it's the number in front of the x squared, and b is 5, the number in front of the x. So x equals negative b, so negative 5 over 2 times 1. So I can write that as negative 5 over 2. So the equation for my axis of symmetry is x equals, you can either leave it as negative 5 over 2, or you could say negative 2.5. So this parabola gets cut in half at x equals negative 2.5. Okay. To find the turning point, we need the axis of symmetry. These two go hand in hand. So what we're going to do is we're going to take the value we got for x, which is negative 2.5, and we're going to plug that in for x and get our y value. So y equals x squared plus 5x. So I want to figure out y. So I'm going to put negative 2.5 in for x both times. So now what I would do right now, everybody, is I would take your calculator, hopefully it's out, and I would just plug this in, just into your home screen, not into your y equals. Just plug this in so that you can find what y equals. So when you do that, you should get y equals negative 6.25. So that means that my turning point, or my vertex, is the point negative 2.5 comma negative 6.25. Okay. I know that's a lot. It's a lot the first time you try to do it. So I'll do 2 more with you, and then your homework or your assignment for today will be to do exactly like this, one of these on your own. So let's take a look at the next one. It says identify the key features of this quadratic equation. So now we have y equals negative x squared minus 3x plus 4. Okay, so to find the roots or the zeros, we're going to set it equal to 0. We're going to take y and set it equal to 0. So 0 equals negative x squared minus 3x plus 4. Okay, I personally don't like that negative there. So what we can do is we can divide everything through by a negative 1. As long as we do it to everything in an equation, that's okay. Just so it looks a little easier for me. Now I have x squared plus 3x minus 4. Okay, I'm just going to come up here. So I have 0 equals x squared plus 3x minus 4. And now here comes the factoring again. So I have x squared plus 3x minus 4. So what kind of factoring does that look like? Hopefully you said tram. Yeah, it is a tram. I need to find 2 numbers that multiply to negative 4 and add to 3. So we could set up our tram while we're thinking about it. If you need to go into your calculator and figure out those numbers, you certainly can. You can even pause while you're doing that. The 2 numbers that multiply to negative 4 and add to positive 3 are a positive 4 and a negative 1. Okay, so now I'm factored. The next step, we got to tee it off and set each factor equal to 0. So we get x equals negative 4 and x equals 1. So this parabola crosses through the x-axis at -4 and 1. As a matter of fact, why don't we put this into our calculator and just look, just so we can see that it does in fact cross through the x-axis at -4 and 1. So into your y1, into your calculator, in the y1, if there's something there, press clear. What I'd like you to do is type in -x squared minus 3x plus 4. Go to graph and just take a look. Where is that parabola crossing through the x-axis? Well, it is crossing through the x-axis at -4, and it is crossing through the x-axis at 1. So I'm just going to draw a little sketch since I can't show you my calculator. So my parabola looks something like this. Hopefully that's what yours looks like as well when you typed it in. So remember, the roots are where it crosses through the x-axis. So right here and right here. Well, -4 is right there and 1 is right there. So the answers we got algebraically match to our graph. Excellent. Okay. Like we did last time, let's do the y-intercept next. The y-intercept is where the parabola crosses through the y-axis. To find the y-intercept, remember, we're going to set any x's we have equal to 0. So I have y equals -x squared minus 3x plus 4. I'm going to take each x value and I am going to put a 0 in for it. So y equals -0 squared minus 3 times 0 plus 4. I like to use the parentheses anytime I'm substituting in a value. It just kind of helps me when you're plugging into the calculator. That way there'll be no mistakes. So when I do this, I get y equals 4. So this parabola crosses through the y-axis at 4. Go back to your calculator. Hopefully it's still on. You still have that parabola graphed. And yeah, I can see on my screen that it crosses through the y-axis at 4. That would be, if you look at the graph, here's my little sketch, that would be right there. Okay. All right, let's now find the axis of symmetry. So again, we're going to need that equation, x equals -b over 2a. So if we look, my a is going to be a -1, and my b is a -3. I'm just looking at the original equation. The a is the number in front of the x squared, so that's a -1. The b is the number in front of the x, so that's a -3. So let's plug in. So x equals -b. So it's a -3. A -3, as you know, is a +3. Over 2a, so 2 times -1. So when I plug that into my calculator, I'm going to get x equals -3 over 2, or we might want to write it as x equals -1.5. -3 over 2 is -1.5. Okay, take a look at your calculator picture again. Does it seem to be cut in half at x equals -1.5? I think so. That's exactly what it looks like to me. Here's my little sketch. This is where it's cut in half. If I'm looking at my graph, it is exactly at -1.5. So we know we did a good job with that. Okay, and the last thing to find is the vertex. Well, as we said before, the axis of symmetry and the vertex go hand in hand. They're really important to each other. The vertex is the turning point. So what I'm going to do is I'm going to take that -1.5 that I just got, and I'm going to plug that in every time I see x in order to get a y. So I have y equals -x squared minus 3x plus 4. I know that I need to plug -1.5 in for x in order to get a y. So I'm going to type that exactly as is into my calculator. I'll do it with you just so you can do it right now. Type that into your regular screen, not your y equals. We're just trying to get an answer. And I get 6.25. So my turning point is negative 1.5, comma, 6.25. Take a look at your graph again. Just hit the graph. It's a little harder to see because it's got decimals in it, but it does really look like the turning point is at negative 1.5 and 6 and a little bit more. So it looks like we did a good job with that too. Okay, I'm going to do one more with you. This last one, and then you're going to try one on your own to submit. Okay, identify the key features of the quadratic equation algebraically. Alrighty, so here is f of x equals x plus 3 squared. So let's find the roots or the zeros. So remember to do that, to find the roots, the zeros, the x-intercepts, we're going to set the y value equal to 0. So 0 equals x plus 3 squared. This to me looks like a great candidate for the square root method. So I'm just going to take the square root of both sides. Square root of 0 is 0. We could say plus or minus 0, but it's just 0. Equals x plus 3. I need to just solve for x, so let's minus 3 from both sides. Negative 3 equals x, or x equals negative 3. We only have one root here. You know what? Let's take a look at it. Let's go back to our y equals. Let's clear what you have in there. And let's type in x plus 3 squared. Let's go to graph. And sure enough, my parabola is touching the x-axis at negative 3. So again, I'll make you a little sketch. Looks, oops. Sorry, everybody. It looks something like that. My sketch is not perfect here at any means. This should be up. Okay. So it's touching the x-axis at negative 3. Okay. Let's now try the y-intercept. So the y-intercept is when x is 0. Okay, so let's do it. Y equals, I'll write out the original first, and I need to put x, 0 in for x. So y equals 0 plus 3 squared. Well, y equals 9. Okay, you can use your calculator if you're not sure. So my y-intercept is 9. It crosses through the y-axis at 9. And I can look on my graph, and yeah, it does look like on my calculator it is crossing through at 9. So you know what? I am actually going to fix this. Sorry, everybody. Just so you can kind of see it a little bit better. It kind of looks more like that. And yes, let me get a little highlighted for you. This is about at 9 if you look on your calculator. Okay. Let's do the axis of symmetry. Again, formula is x equals negative b over 2a. Okay, so we're a little bit stuck here. What we're going to need to do is we're going to need to get this out of this form, this x plus 3 squared form, and into standard form in order to find what a and b are. So this is a little trickier, but we can do it. So we have y equals x plus 3 squared. So that's the same as x plus 3 times x plus 3. So I know we like to do the box, so we need to multiply that out. So x plus 3, let's multiply those. So I get x squared plus 3x plus 3x plus 9. So I get y equals x squared plus 6x plus 9. So now I can see what my a is and what my b is. So a is 1, b is 6. So x equals -6 over 2 times 1. X equals -3. Okay. And let's just look back at our graph. Hopefully you're looking at the one on your calculator. If I look at my little sketch here, yes, it does get cut in half at -3. Okay, one more part. Let's do the vertex. So the vertex, we need this x equals -3 from our axis of symmetry. Remember, these go together, hand in hand. So what I'm going to do is I'm going to put -3 in every time I see x. So we have y equals x plus 3 squared. I always like to go back to the original. Y equals -3 plus 3 squared. So y does equal 0 in this case. So my turning point is -3, 0. And let's consult one more time our graph. I'm going to consult my graph on my calculator, but let's look also at my little sketch here. Here is the turning point, or the vertex, right there, at -3, 0. Okay, I know this was a lot of new information, so I want you to try the one that I gave you separately as your assignment to hand in for today. I hope everybody is doing really well. I miss you guys. Bye.